Okay, thanks, Daniel. I'm gonna start right away. Yeah, as Daniel said, I'm Sebastian, work at Sipgate, and today I'm gonna talk about modular and test-driven SIP routing with Lua. I have worked at Sipgate for 12 years now, and so almost from the start. We were the first voice over IP service provider in Germany, started in 2004, and we are currently still active in Germany and the UK. And we started first with private customer products and later added some a business customer hosted PBX solution, became a full MVNO in the Telefonica network, which gives us the flexibility to offer pretty good integrated products with voice over IP and mobile. And what sets us apart a bit from most of the telcos in Germany is that we hate black boxes, and we try to do everything we can in open source and in-house, so from the back end to over the middleware, the front end, and of course also the telephony part. And yeah, of course we use Kamailio, and that's all over our network. We use it as a registrar, a proxy server for NAT handling, IPv6 to 4 conversion, carrier interconnects, and all that stuff. But we have a huge problem. At Sipgate, over the last years, the methods of how we develop our software and we run all our infrastructure have changed dramatically. We do agile, we have fast cycles, many releases per day. We try to make our modules as small as possible. We unit test everything that we can. We deploy it with continuous deployment solutions, and we are in a permanent process of refactoring functions that don't suit our needs anymore. On the other hand, we have the telephony side that has grown organically since 2004, adding some stuff here and there, and it has been maintained by the core telephony guys. And so we have 40 developers in our company, but only 4 people can read and write Kamailio logic or telephony logic. And all those learnings that we have from our software development haven't made it over to the telephony platform. And the real problem is nobody except those 3 or 4 guys wants to touch the telephony system. And that makes it a bit hard to develop new telephony solutions, because they are always pulling our 3 or us 3 people to help them, and we want to solve that. And there are 3 problems with it. One thing is readability of the Kamailio route or config, and I have an example. I'm pretty sure you've seen this kind of mess. There are named routes, there are numbered routes, there are some named flags or even numbered flags, and then some of that Kamailio logic that you can read if you're into Kamailio configuration. But as a programmer coming from somewhere else, you really have a hard time doing that, and you probably won't have enough time to dig long enough into it to understand everything. The other one is the config file size. Oops. Should be something happening. Come on. Yeah, as you can see, our main zip proxy has a configuration file of 3.6K lines. And that's even for us that we have to deal with it all the time. That's sometimes kind of hard to read. Of course, there are some includes and everything, but yeah, as I said, grown organically. And the third thing is testability. We have those 3.6K lines, and they are all untested code. And of course, we can deploy it or we can run a syntax check. We can deploy it into a test system and place some automatic calls. But that's if one of those automatic test calls fails, then you still don't know what actually went wrong there and where you made an error. And we want to change that. So overall, that's a mess. And how do we fix that? Fortunately, Daniel and the whole Kamailio team have come up with some solutions. That's the older one. We have different applications where you can write the routing logic in a language of your choice. Okay, not the one of my choice because AppRuby is missing. But you can take Lua, Python, JavaScript, or even Java, Mono, Perl. When doing this, you can call some functions out of your main Kamailio config script and extract some functionality. And the newer version is the Kemi. Daniel has talked about it also this year, and he has put a lot of effort in there. Thank you, Daniel. And with Kemi, you can really replace the Kamailio config file. So that's probably the way we want to go. But why did we choose Lua? Because there is a speed comparison somewhere on the Kamailio wiki, and you can see there the average execution time is almost there where the native interpreter is, and that's why it was a no-brainer to take Lua, because we want speed. And another reason is it's easy to learn. When we started that one project where we wanted to replace the configuration file, we had, or none of us had written productive Lua code before, but we read some examples and we were able to start right away. Yeah, it's really easy to read and to write, and for me, not being a programmer, it's kind of hard to contribute with Java code that the real developers write, but with Lua code, there are not so many differences, and even I can learn it. And we hope we have less fear of a lot of people of changing something in Kamailio. And the third thing is we can work test-driven. As I said, it's impossible with the native Kamailio language, and the goal is to know if we broke something before we deploy a new version. So I took the example Kemi file that comes with the distribution of Kamailio, and you can see there the native function has almost 1,000 lines, but the example file of the Kemi Lua version is still too long for what I think. And you don't have to read that. I know it's too small, but that's the request route written in the Lua way. And but you can see there, you still have to interact a lot with Kamailio, and you have to know a lot of the Kamailio syntax, and that could be a hurdle for developers coming from somewhere else. And the one big Lua file is still not testable. But one thing that is testable is a library. And so we why don't we encapsulate all those Kamailio functions in easy-to-use native functions? You see an example there. Those two parts do exactly the same, but or should do exactly the same, but the lower one is better to read. And you can reuse often used calls, don't have to write the same Kamailio syntax all the time, and you can test it. So this is the goal, how the request route should look like in the main Kamailio script. So we just include our library, and then we call one function of the library. But how do we get there? At first, you have to, of course, install some dependencies, and you have to use Lua version 5.1 because that's the version that Kamailio is tied to. And then for testing, we use the framework called Busted, and both these packets can be easily installed on a Debian stretch system with apt. Then you have to create your library. You define your functions, you write your tests, and then you make those functions work. And so let's start by creating the library. There are two ways. You can either put the library in one file, and then you can place it into a well-known destination where the Lua interpreter will look for, or you can place it into the same directory where your main script lives. Or the other version is you can create a directory containing multiple files so you can split up your library. That can be handy if when the functions start adding up. The most important file in this directory is the init Lua, because that will be the entry point where the interpreter looks for. And if you don't know what the paths are that your interpreter looks for, you can just fire up the Lua interpreter and then try to include some non-existent module, and it will show you where you can place your library in. Now that we've done that, we can start writing our library. And this is just those are just a few lines, and the most important ones are those. You have to define a empty table, because in Lua almost everything is just a table, and then you have to return this table to the calling script. And in between, you just define all your functions that you want to write. And if you need some other libraries or some submodules, as you see on the top, you can just include them there. And after you've created your library, you start writing your function. I've taken one example of our main Kamailio proxy config. This part lets our users suppress their caller ID on a per call basis, and that's And for that, they can dial *31 in front of the request URI, and then we will do something. And they can append after the *31. They can still put another star or a pound, depending on what device they use. And so we want to write that in Lua. And that's what I came up with. So you see again, we require some modules. I need the regular expression library, and then I define the headers module here, and then I write my function. I have to admit, for for time purposes, I have already filled the function, but if I wanted to do it really test-driven, I would have just specified the function name and then would have written my tests and then afterwards filled it with functionality. But for time purposes, it's already filled. So what I'm doing here is, just get the request user, then check if I find my pattern, and if I find it, I modify the request URI, and if it is an invite, then I set the privacy ID header. So that's basically the same functionality than the original Kamailio code that we saw before. And after we've defined or written our function, then we can define or write a test. We have to require the busted framework, and then we have to include my module that I want to test, and then I can start writing the test. So that's busted syntax, but the main part is that I call my just written function, and afterwards I check that the return values or the what is actually happening in there is the way I want it to be. So I check that KSR PV set is called with the correct request user and that the privacy ID header is added. So let's run this test. And yeah, what Lua now is telling me is that there is a global KSR. We all know that from the Kemi framework. That's the one that Kamailio provides us for interacting with Kamailio. But it's not there if I run it on a standalone basis. So what I have to do is I have to create a mock. And there you can see I initialize I write a function init mock, and there I have a KSR mock, where I define all the KSR functions that I need for testing my function, and I can specify what those functions should return. So you can see here that they, if I want to get the request user, then I return whatever I pass in there using the options parameter. And I also mock my internal isInvite message, because that comes from another module, and I only want to test this module and this function, and so there's no need to actually call this the message module. So I mock that as well. And after defining my mock, I can initialize it in the test, and I call the init mock function, pass the request user and the isInvite return code to it, and then I can rerun my test. And yay, got my first test. But as I said, there are different ways to write this *31 thing, so we have to add some more tests. So we check if it's *31 star, *31 pound, and even an URL encoded pound. We've seen that from some devices. And there are two tests at the bottom that are the partially or complete negative tests. So the second to last test is when the caller doesn't dial *31, then we don't have to change anything with the request URI, and we shouldn't add a privacy ID header. So we just make sure that those functions are never called when running it with those input parameters. And the other one is the customer wanted to suppress the number, but it wasn't an invite, and we don't want to append the privacy ID header to a cancel, so I check it like this. And then we can run it again. And we see our tests are now totally fine, but the code apparently isn't. It tells us that the function wasn't called with the right arguments. So we have to look into the code again, and that's the point where it is. And yeah, of course, I forgot something. So I fixed my code, rerun my tests, and finally I got 6 successful tests. Yay, got my function tested. And now, if somebody changes something in this function, I can make sure by running those tests before deploying it that nothing got broken. I know that was a bit dry if you haven't tried it or if you can't play around with it. That's why I tried to take the example config and make it a library. So I replaced a lot of functions with from the example Lua chemiconfig by library functions, and then included the function. And some of them are even tested. So I'm not done yet. It's a work in progress, and but if you want to play around how it feels like having a library do all the work and being able to test everything, then just clone it from GitHub and yeah, feel free. That's it from me.
Hey. Yeah, this is something I really learn a lot because I'm also trying to use Lua whenever I need more flexibility than the default config file. So, questions from the audience here. Otherwise, I'm going to start myself. Don't turn me on with Lua. Okay, so I have then myself. What would be somehow the way to make it easier from like Kamailio point of view, because that's like maybe having some include files, like header files that make it easier to integrate it with this testing environment. So it's anything that can be made inside Kamailio code to make it a bit more friendly for these testing frameworks, or you are happy with what we have now?
No, actually I'm not, and probably a good mock that you can only need to include for testing purposes would be great, but I haven't had the time to figure out how to do that. So I'm currently specifying all the mocked values that I need to mock inside the test file, but the better version would be to have one big Kamailio mock that returns you whatever you want or whatever you need.
Okay, and the last question. Do you sleep better now over the night when deploying a new Kamailio instance after running the test?
Yes, actually we do.
Thank you, Sebastian. Really, this is something that I need to review again. And
oh yeah, and if you're